everybody. I'm glad to see so many of you came out to see Horizon House's favorite ornithology professor here. At least he's our ornithology professor. He knows more, I'm sure, about birds than all of us put together. So I think we're in for a treat this morning as Gordon tells us all about gulls. And there may be some around to visit as he goes on in his little talk. And as Gordon says,
there goes one right there.
Hey, there you go.
So I will keep this brief and turn it right over to Gordon, whom I'm sure you all know.
Good.
Here he is.
Hello.
Thank you, Annemarie. Actually, I've never taken an ornithology course. Never taught ornithology. But I got hooked on birds when I was a kid. When I was around 13, I made this discovery. People got paid to do this. And that's the story of my search for a career. But we'll leave that aside. I didn't bring any visuals. I got a couple of books with pictures of all sorts of gulls, but you know what a gull looks like. But I want to explain to you what it's like to be a gull, which is very, very different. And the first thing is, they're not seagulls, they're gulls.
Right.
And I don't want to hear seagull anywhere here. Okay, I'm going to be alert for that. And the reason for that is that there are gulls that never go to sea, in fresh water entirely, and others have very complicated relationships with the sea, and I will try to explain why that is true. But let me start with the one really true seagull. And this is a very unusual gull. It's the Galapagos swallowtail gull. How many of you have been to the Galapagos? You've probably seen that gull. It's sitting on the ledges there, doing nothing during the day, and it has a great big eye. And it's nocturnal. At night, when it gets dark, it takes off and flies out to sea and feeds way out at sea at night. And why does it do that at night? There's a great big diurnal migration at sea that you don't know about. That during the day, the zooplankton, the little animals and stuff that feed on the little tiny plants, migrate down below the photocope where they can't be seen, and they come up at night and feed at night up on top. And this is an amazing diurnal migration. And so when the gull goes out at night, that's when everybody's up there feeding on stuff, okay? If the swallowtail gull flew out there during the day, there would be nothing for it to eat, nothing. So this is and this is a part of the major mission I want to talk about is it depends, the whole life of gull depends on where stuff is brought up to the surface for one reason or another. Because out at sea, the organisms that are the photosynthesizers are single-celled algae or cyanobacteria. They're single cells. And this is how it's different from on land. The photosynthesizers are the biggest organisms in the system, right? And we have very short food chains. It's willow, moose, wolf, it's over, or grass, zebra, lion. They're really short because you're starting with the primary producers being big, and they're the biggest things there. In the aquatic marines, they're the smallest. They're single-celled little things, and they're out in the water, and everything out there has a tendency to sink. Okay, they'll sink down, and that's how stuff goes down. The oceanographers refer to this as the fecal express. The things going down to the bottom, and so there's nothing up there unless things move to keep it up there. And this is true for the plants out there, the little tiny algae and cyanobacteria. They sink too, so they have to be in places where they're constantly kept up where the sunlight is. So the whole problem in the aquatic environment is you have to have the sinking feeling about what's going on. So this will become important for everything I talk about. So So understanding the marine environment is totally different. And in the freshwater, it's also fascinating because in order to have freshwater be productive, you got something that has to turn things over, bring the nutrients up to the surface. And the story of what goes on in Lake Washington is absolutely fascinating and exciting, and I'll be happy to talk about it afterward if you want to, but it's not that highly relevant to the gulls right now. But where does the upwelling occur that keeps the plants up there in the ocean and things for the gulls to feed upon? And there's the big ones. The biggest ones are along the coasts of continents, and the biggest and most spectacular one is the west coast of South America. We've got cold water flowing toward the equator, and it gets all the way to the equator, and you have penguins on the equator there, right? But the important thing there is that's a big area with southeast winds. All along that coast, it's this prevailing southeast wind. It's pushing water away from the coast. It's upwelling. And what upwells up's goodies. So that's bringing stuff up. And I'll talk about a couple little ones that are, and that's highly relevant because some of our gulls go in winter down there in the upwelling zone, okay? But there's smaller ones that are of interest. And I'll tell you, one down in the Gulf of California. We've got this long gulf that's separating the Baja California Peninsula from the mainland, and that's really arid there, right? There's virtually no fresh water flowing into it, and it's hot and sunny. A little bit coming in at the top of the Colorado River, but that's pretty much gone. And so there's a deficit of water, so more water is evaporating and flowing in by far. So the water has to flow in somewhere to replace it. And it comes in from the bottom, flows northward, and then two-thirds of the way up, there's a ridge and islands. And here's the ridge, and up it comes. It upwells. And it's a permanent upwelling there. And the seabird colonies that are on those islands are unbelievable. And one of the gulls that we have here in the fall and winter breeds there and comes up here afterward, and I'll talk a little bit about it. But that's an upwelling zone. It has 2 species of gulls breeding there, and a lot of other stuff. Turns all over the place. It's one of the most unbelievable places to go, but it's permanent upwelling because water has to come in because nothing flowing in from the land. It's hot and sunny, and it's a deficit. Another one, which is interesting, which is also relevant for gulls, is the Mediterranean. Now, the Mediterranean is a subtropical hot body of water, and there's not a lot of fresh water flowing into it. From the south, there's only one, and that's the Nile, and there's not much left of that anymore. And then some others coming in from the Bosphorus, from the Black Sea, and that's good upwelling, and that's a good place for gulls right there, by the way. But the important thing is, there's a lot more evaporation in the Mediterranean that flows in from fresh water. How does it come? There's a constant flow in from the Atlantic, and there's a ridge right at the entrance to the Mediterranean Sea, right where it's narrow, and there's permanent big inflow of water and upwelling there. That's all going on constantly because there's a deficit of water in the Mediterranean. More is evaporating than flows in anywhere else. So and that's one of the best places for gulls in the Mediterranean is right there at the beginning and flowing around. So there are these little upwellings, and so in the sea is the question, and in freshwater in general, what is it that keeps stuff up? Because unlike in freshwater, the trees stand up, and in the land, the trees stand up, no big problem, right? So that's easy problem. But in the water, it's always upwelling. What's going to keep stuff up into the zone where it can take place? And that tells us where the gulls are. The gulls are where it upwells. And for productivity there. Probably most of you have been to the Hawaiian Islands, right?
Yes.
You may or may not have noticed that you didn't see any gulls. You didn't. If you did, you were hallucinating, I'm sorry. But there's no gulls there. You may have seen albatrosses or some shearwaters. There are no gulls out there. So the reason that the gulls are landlubbers is that the places where the upwelling is occurring is right by shore and almost everywhere. And that's why, don't think of them as, did I hear seagull? I will not. They're really close to land, but that's where everything is happening. Now, most of the gulls, there's about 50 species of gulls in the world, most of which occur in the northern hemisphere. And ironically, the reason there are so few gulls in the southern hemisphere is there's no land. That sounds funny, doesn't it? But if you go to the same latitude as Seattle in the southern hemisphere and go around the world, you'll be over water 98% of the time. 98%. The bit of Patagonia and a little bit of the South Island of New Zealand, that's all you'll hit. There's no land down there. So that's why there isn't a lot of place for gulls. And there's good upwelling at the bottom of South America and up that west coast, and there's some gulls right there, a few species of gulls. The same occurs in the bottom of Africa, and there's an upwelling zone, and there's several species of gulls, and a penguin there, by the way, too, in South Africa, upwelling right there. So that there's just not much land and not much, and no fresh water, and we'll see how important fresh water are for gulls in just a minute. So the southern hemisphere does have gulls, a small number of species. They're around the little bottoms of those continents where there's some upwelling. They're very restricted there. And there's some pretty beautiful, wonderful gulls I won't talk about there. But but the vast majority of gulls are in the northern hemisphere. And that's because there's a lot of land. How could that be? Okay, so let's look at it. First thing to remember is that most of the high latitudes where gulls breed 15,000 years ago were under glaciers. Okay? 10,000 years ago, if I had tried to give a talk here, we were under a glacier, right? And so this is all of this stuff we see in the northern hemisphere is very recent because it's just melted back. And the full range of the glaucous winged gull, which is our present west coast from Puget Sound up until the Bering Sea, all of that, except a little bit on the coast, was under ice not too long ago. So most of the places where we're seeing gulls breeding now in the northern hemisphere were under ice. So it's melted back. But what the glaciers do, they do hell with flow patterns. They create marshes, they create lakes, they create stuff all over. They create abundant aquatic environments, and they create places that are great for gulls. So the northern hemisphere, it's the glaciers, and that's where all the land is. You know, if you look at the globe, almost all of the land is there in the northern hemisphere. You've all seen the little curve of the CO2 done from the Hawaiian Islands, that little CO2 going up. You know, it's jagged, right? Have you noticed that jagged? Every year it goes down a little bit. That's the boreal forest turning on in the spring. The boreal forest, it sucks enough carbon out of the atmosphere to bring it down a little bit every spring. So next time you see that curve, look, it goes like this. It goes up, but it's like every year, and it's the high boreal forest turning on. So the long days, and you know there's high productivity there. You don't go to there without a net, mosquito net, right? The insect is highly productive and all sorts of stuff going on. So it's wonderful. And so it's the glaciers that have contributed so much. And most of the places where our gulls are breeding in the northern hemisphere, they couldn't have been there 20,000 years ago. We don't know where they were, but we know that they were where they are. And this means that gulls have been speciating very rapidly. The gulls love what the glaciers did, and they also love what we do. We create water all over the place. Eastern Washington 100 years ago was a dry place and there's water all over the place. Now we've created lakes, we've created gull habitat. Gulls are flourishing in Eastern Washington where they wouldn't have been not too long ago. And so Gulls are among the birds that think what we have done to the environment is pretty great. And so there are probably more gulls in North America now than at any time in history. So they really think human beings are pretty good bonanza. And you know, they're nesting in the tops of buildings here. You know, they're nesting on the top of the center here, and we're watching them now. If we can see from Joyce's room, there's a pair that's got a couple of chicks now, and they're feeding them. Where do they go to get the food? They got to go out to the water, right? So, and so one of the problems with something like gulls is that they're big enough that they're very conspicuous. You can't hide nests very well, can you? So it's all biparental care. You can't get along without two birds there because they have to have some protection all the time. Because you can see down here, if they leave an egg unattended for a day, the crows will get it and go. So the gulls are like most birds, they're biparental care, which is very different from mammals. Mammals are almost all entirely female parental care for a very simple reason. Male mammals don't make milk. So the whole productivity that keeps things going is entirely female. And so almost no male mammals do anything. You watch the grizzly bear walking around, it's the female with cubs, right? There's no male around. Or the lion or the cheetah. So almost all of the care in mammals is female derived, and it's because of the nutrition. But birds, other than laying eggs, males and females can do everything the same, and in most birds they do. And in bigger birds like gulls, it takes two. You can't leave it unattended. If you leave it unattended, something else will get it. And also, because they're big and conspicuous, gulls have to breed in places where mammals can't get out. They have to place where the mammals can't get, because if a coyote or fox gets in, it's curtains, because they can't defend against that. So gulls are always having to nest where they're kept free from mammals. And that means on islands, on the coast or islands inland. If you're driving I-90 to Spokane and you get to Sprague Lake and there's a rest stop there, and there's an island out in Sprague Lake that has a big colony of ring-billed gulls. In the right sort of season, if you stop there, the ring-billed gulls are all over the campground, the stopping ground, trying to pick up scraps and stuff. So the gulls have to be kept away from mammals because you can't hide them. You're too big, you can't hide anything. So that means either or in marshes, where it's difficult for mammals to get out. So it has to be mammal-free. And that's a constraint as to where gulls can and cannot breed. And the wonderful thing about what glaciers do, it creates also islands and disruptions. So it's a wonderful place for gulls. And so gulls are proliferating as a result of glaciers. So gulls it's biparental care, and both males and females incubate, and they mostly, because they have to go far away, they come back and they regurgitate the food, right? So if you see a gull coming back and it doesn't have anything in its bill, and it will stand up by the chick and starts doing like this. And in the spring, all these gulls get a little red spot on the lower mandible, only in the spring, and you may notice it. And that's what the babies peck at. The babies peck at that, and the gull regurgitates, and the babies pick it up. And baby gulls, baby birds fall into two major categories. Altricial, like most of the songbirds, they're tiny, naked, all they can do is hold the mouth up. And precocial, like ducks and chickens who they hatch up, and they can run around and feed themselves. Well, gulls are precocial, but because they're nesting where their food isn't, they have to be fed for a long time. And they have to be fed till they can fly out. And so birds very rapidly grow to full size, and birds never grow again. after they reach full size. You can change size, what kind of feathers do you can add stuff to a bill and take it away from them. But birds reach full size and never grow again. And that's the constraint. You don't start off with a half-built flying machine. Doesn't work. And most mammals continue to grow, and other things, but mammals that also reach the same size and never grow again are bats. Flying machine, right? You don't start off with a half-assed flying machine. And so they come to this and develop it, so it's very rapid to full size and never growing again. But they could change a lot, because you could change your feathers. And interestingly, many of our gulls, including this one, take a glaucous winged gull here, our common one that I'll talk about a bit more. Takes 4 years to reach the full adult plumage. And so and everyone we see out sitting on the convention center is at least 4 years old. You can tell how it looks. It's at least 4 years old. Where all the young ones are out on the water. And basically, you go from being quite brown and streaked and stuff like that to getting closer and closer to the adult as you get full size and ready to breed. And this isn't because it necessarily takes 4 years to get, you're right, the first summer you're full size, and you know how to do it, but probably, this is very interesting why they take so long to mature, because there are some gulls that get it right away, and geese and stuff are big enough, they do it right away. You don't have to take 4 years to get those new feathers. And this must relate to the fact that there's such limited places they can nest because of mammal-free places. That there are fewer places, they're far more individual. And all these gulls out here are adults, you notice. All the gulls you see over the convention are at least 4 years old. They're not breeding. They're just not breeding. And there are enormous numbers of non-breeders because of the limitation of where you can actually nest. And this is one of the interesting patterns. Now, back to what gulls look like. You know, most gulls are quite like, but one of the interesting patterns is that quite a few gulls have black or dark brown heads during the breeding season. They develop them during the breeding season, and then they molt out of them, and none of them have black heads in the winter. And one of the gulls, we've got a couple of gulls here that are blackheads in the summer that I'll talk about a bit more. But this is one of the interesting things that develop these plumage patterns for the breeding season only, and they drop it, and they become very inconspicuous. Another thing of interest is that almost all gulls have dark black on the wingtips, some amount. Ours is one that doesn't called the glaucous winged gull because it doesn't have that, but most gulls do have varying amounts of black on the wingtips. We think the reason is that this melanism gives strength to the feathers. It's strength to and that's what the feathers are likely to wear a lot. But ours doesn't have it, and some gulls do and some gulls don't. It seems to be best developed the black wingtips in things that are highly migratory, at least that wear it out a lot. But that's one of the features of gulls is that mostly they have varying amounts of black on the wingtips, and that's one of the ways you identify them. So gulls have this complicated biparental care. They're very limited in where they can nest, because they have to be where mammals can't get at them, and that really limits so that there's limited places where they can occur. And one of the things that the glaciers have done up there is to create a lot of places where they can breed, much more than there would have been without. So the prairie potholes, that's all glacial stuff. And of course, what's along here? Remember, 10,000 years ago, we wouldn't be talking here. Because this has all happened to come and create it. So gulls, the reason there are so many more species in the northern hemisphere, ironically, is that there's a lot of land. And it happens to be that land has been molded by glaciers. And gulls love what glaciers do to the environment. So this is a bit of sort of surprising history that you wouldn't expect. when I tell you the reason there are so many gulls in the southern hemisphere is that there isn't land, that sounds really crazy, doesn't it? But that's what it is. So, having said all this, let me talk a little bit about the gulls that we do have here, what you want to know about. And of course, the most common one, the one that breeds in Seattle and all around here, is the glaucous-winged gull. And it's called glaucous-winged because it doesn't have black wingtips. And its range, we're at the southern ends of the range, so Puget Sound is the southern end of its breeding range, and goes up the coast to the Bering. And it's a common gull all along the coast, and it's almost everywhere. It's almost entirely a saltwater gull, but right next to the coast, because that's where the upwelling is. But it's also, with everything we've done in eastern Washington, they're showing up a lot in eastern Washington too, because they can handle fresh water. But that's an interesting situation because, and I want to take a minute to say about, and that is gulls and mammals evolved on land, right? When the stuff came out of the water, probably there were some fish and things like that, but there's nothing like birds or mammals. This is all evolved once they got out on land. So they evolved in freshwater environment, very different from saltwater. So gulls and marine mammals face the same problem of the ancient mariner. Water everywhere and not a drop to drink. And the reason that is that we can't make urine concentrated enough, so if we drink seawater, we draw off a lot of water trying to get rid of the salt. And so we can't do it. So gulls face this problem too. And you won't see it here on the freshwater. If you go out to West Seattle and look at a glaucous-winged gull, they have to unload salt. They have to unload salt. And you'll see them drip salt, highly concentrated salt dripping out of the corner of the eye. They have the same problem we do. They got to get rid, and the marine mammals sell, but they produce really concentrated urine. So you got to concentrate urine enough, then you can get rid of it. So you can drink salt water. Because when the gulls are out there and feeding and drinking salt water, they got to unload salt. And so salt is a big problem. And there's so many things that relate to how the world works, to the fact that plants, vascular plants, when plants crawl, it was tiny stuff, Plants evolved on land. Plants evolved not to need salt. Plants don't produce and use salt. We evolved a nervous system in the sea. We have sodium pump, right? We need salt. And the big problem of mammals, birds, and all kinds of things on land, you got to get salt. And if you want to shoot a deer, well, the best thing is put a salt lick and it'll come. So salt is a wonderful thing, and a wonderful history about the role that salt has played. But salt is such a big deal because our nervous system and everything else evolved in the sea. All the rest of it evolved in fresh water, and there ain't any salt there. And salt is a big problem. And so the role of salt in history, I won't go there, but it's massive. And there's a history of this, evolving in the ocean, coming to land where there isn't any salt. And another minor one, of course, is iodine, which is a lot of it in the ocean, none of it on land. And you get further away from the ocean. And one of the best things that ever happened for human health is the formation of iodized salt. When I grew up in Wisconsin, in the middle way, and before there was iodized salt, and you saw people with goiter and large thyroid glands, they're working hard because they need iodine. They're short of iodine. And iodized salt solves this problem magnificently. One of the most important medical inventions. It seems really simple. It isn't done enormous stuff. So salt is big. And salt is big, and birds face the same problem. Water everywhere, not a drop to drink. They got to get rid of salt when they're in salt water. Fresh water is not a problem, of course, but in salt water, it is. So, gulls face, you might think, gulls face a problem in the ocean. Yeah, they got a salt problem. Just like you and I do. So, enough of, I think this may give you an idea that what it's like to be a gull is not what you might have expected it to be. It's rather different and complicated. So let me look sort of in detail at the particular gulls that we have right here, because we got a bunch of interesting ones, and they're very different, and you might find that interesting. The most common one, and the one that breeds all over here, of course, is the glaucous-winged gull. It's a marine gull, but it's a coastal, and right up, and I mentioned it goes from here up to Alaska. If you go out on the coast, it's a totally different gull from the coast here south to the southern California to northern Mexico. It's the western gull, and unlike the glaucous-winged gull, it has a dark mantle. The whole back and the top of the wings are dark. It's quite a dark-backed gull, and very, very different from the glaucous-winged. But you don't see it in here. If you go out on the coast, you'll see, and anywhere if you're on the coast from the Olympic Crest south through California into northern Mexico, the gull you see is the western gull, and it's a black-backed gull, very different than ours. Another gull, which is common and breeds commonly in various places in eastern Washington, including Sprague Lake, but also other places, is the ring-billed gull. And it's an adult kind of black ring on the bill. It's a much smaller gull than the glaucous-winged gull. And it's common, it breeds a lot of places in eastern Washington and all across North America. It was the most common gull where I grew up in Wisconsin. It's all across, and most ring-billed gulls never go to salt water. They're in fresh water almost all the time, including a lot of, those that come out here and winter out here from places in the interior who got to get out where it freezes. They're likely to be inland. One of the best places to see ring-billed gulls in the winter here is to go to Green Lake. And you see them in the grass there. So they may go to salt water and something, but they don't have to. And much of the range across North America where the ring-billed gull is, there's no salt water, and they don't go anywhere near salt water, although they can handle it, and they know how to get rid of salt if they have to. So that's a very common gull, and it's here on the west side in the winter only. It's on the east side all year long. Another gull that's really interesting here is the mew gull. And the mew gull is called that because of the rather interesting call. But it's a gull that occurs all across the northern hemisphere, from Europe across into northwestern North America, and it breeds in Alaska, British Columbia. It's a forest breeding gull, and it's in fresh water entirely in the boreal forest, and it comes down here in the winter. We got a lot of them in the Puget Sound area in the winter. It's a smallish gull, about the size of the ring-billed. It does have the blackish wingtips, and it's a rather nondescript kind of gull, but it's fairly common. Again, it's not too difficult to see it, but there's a fair number of them around. So that's another gull that is here just in the winter. And one of the gulls that we have here that is common, that does have a black head in the breeding season, is the Bonaparte's gull. And this is fairly small gull, and we have it mostly in passage here. It breeds, again, in the boreal forest, mostly in western North America. It nests in trees. It's one of the few gulls that puts its nest up in trees, and that's where it's away from any mammals that might get at it. And we have them here primarily in passage. In the spring, we see them coming through Puget Sound with the blackheads and heading up there. And in the fall, they come down and they don't have blackheads. And in the winter, they don't. And some of them do pass the winter in western Washington, but most of them go on further south. So it's primarily a migratory gull, passing us one way and the other way. And if you want to see with a wonderful blackhead, you got to get out in April as they're coming back north. And there are a lot of them. They were quite abundant in Puget Sound during migration, because it's a very common gull, and it's also very agile. in September here, we have termite eruptions. We have a lot of termites here, by the way. They're wet wood. Good news, they're wet wood termites, not dry wood termites. So they don't affect building, but they're rotting logs and everything. And they come out in September, in the warm evening, September evenings. It's wonderful to see the termites emerging. And they go up, and what's up there? The Bonaparte gulls are eating them like crazy, flying around, grabbing them. And they're quite agile in the air, capturing termites. And other ways too, again, this is upwelling, right? It's a form of upwelling, but also you can see them, and this was also the ring-billed gulls in Wisconsin where I go, they would follow the plow, plows dig up, they bring stuff up to the surface, and they follow the plow and go like this. Another way that they're following that is, if you've been to Glacier Bay and up to go up to the glacier, how many of you have been there? Quite a few of you. When you see a big ice fall coming down, what happens? A mass number of gulls come right in. These are kittiwakes, which I'll talk about. And that brings up stuff. It brings up stuff. The waves crashing brings up stuff to the surface, and the gulls will go right there and ready to get it. So again, it's an upwelling caused by ice falling. So the gulls take advantage of upwelling in all sorts of interesting ways, and they're pretty flexible. They also, I'll tell one other story. The Mormons had the crickets problem eating all of the crops, and they said God sent the gulls from the sea. They were California gulls. They have huge breeding colonies in Salt Lake. They're right there. But again, gulls they don't have to go to sea. They're happy to get there and mop up Mormon crickets. They're quite good at that. They're very flexible. So gulls are pretty interesting. They can adapt to stuff that we've done. And that's why gulls seem to think we've done a pretty good job in making the world. So furthermore, I mentioned one of the gulls, the California gull, which is common here, and it's the one in Salt Lake. But it also breeds in various places in eastern Washington and up through the prairie provinces up into central Canada to these areas. It's a medium-sized gull, smaller than a glaucous winged gull, but medium-sized, and they're common here in the winter. And they fly on further south as well. But again, they're a gull that takes advantage of all the glacial lakes caused by the activities of the glaciers upsetting stuff. So it's a very common gull across central North America into the plains, and it's taken advantage of what the glaciers have produced. And we have them here in the winter, and most of them go on further south in the winter. Now another gull, back to the Baja California, a gull that breeds almost exclusively in those islands, is the Heermann's gull. And the Heermann's gull is a beautiful gull, and as a juvenile, it's just very, very dark, uniform dark brown. But as it starts getting a bit more like an adult, it gets a little bit light in the head, it develops a bright red bill. And following the breeding season down in the Gulf of California, Heermann's gulls migrate north and come up, and they become, in the fall, September, October, November, they're quite common in Puget Sound. But you won't see them right from shore. They're out, further out. But if you take a whale watching cruise or something, at that time of the year, you're likely to see a lot of Heermann's gulls. But it's not one that you would otherwise note. But it's a fairly common bird here, and it's a spectacular bird, that bright red bill when it comes in. Again, that's migration north after the breeding season, and they come on up here. And they're not the only birds that do that. Brown pelicans do it too. We get brown pelicans in the fall coming up. They're breeding down in Baja California. They come on up. So this is not the only thing that happens, but this is a good place to very good foraging grounds, and they come up for a number of months, and it's fairly common. Another gull that is common, but it's offshore and you don't see much, is the kittiwake, the one that's at Glacier Bay. And it's a common gull breeding across the boreal forest, across the Bering Sea, across Europe, very common in and around the North Sea, common bird all through there. And it's a cliff nester, and so it breeds on cliffs. It's got it's got an egg shape that doesn't roll off a cliff. And it's got baby gulls that intuitively understand what a cliff is and they don't try to jump. Otherwise, we wouldn't have these gulls around. The kittiwake wouldn't be around if the babies did. And it's also a place where it's difficult for predatory gulls to get at, so they can defend it easily on this little cliff. And so it's got all sorts of adaptations for cliffs, but it's also, I've watched them on the Homer spit, they nest under the pilings there. But you can see that the minute they see something going on of a sea churning or something, off they go. They're immediately available and see, there's something upwelling going there, and out they go. So gulls look for upwelling. And in general, if you didn't have these concentrations, if you looked at the average distribution of productivity out across the ocean, everybody would starve. It all depended on finding where the concentrations, and when it upwells, it ups goodies. So remember that this is a world, the aquatic world, of where upwelling is what really matters. And the kittiwake, I've seen them on the spit at the ocean shores, but mostly they're off the shore, and you won't see them. Another one that passes by, we see it only in migration, is a Sabine skull. It's an arc breed across the Arctic, and it winters off the west coast of South America, in that upwelling zone, and we see it as a migrant. It's got a black head in the winter, in the summer, in the breeding season, it loses that, but it flies past us and down to winter off the west coast of South America in that magnificent upwelling zone. And there's another gull that we have here that does that doesn't actually breed in the state of Washington, but close. It's the Franklin skull. And there's another one of the gulls that has a black head in the breeding season. I think the nearest breeding colony, the Franklin skull, is at Malheur Lake in southern Oregon. There's a big colony there. But in the Prairie Potholes region, in the Dakotas up into Manitoba through there, that gull is really, it's a beautiful, beautiful gull, but it's entirely freshwater they're breeding. And it's, and it comes, and it also travels and spends the winter off the west coast of South America in that upwelling zone. So some of the ocean upwelling zones are wonderful places to spend the winter. It's not a good place to raise babies. So the relationship between the gulls and the is really complicated. So I hope I've given you a little bit of an idea how fascinating what it's like to be a gull is. And let me close with, was a young girl who went out to see what wonders there might be. She was overwhelmed with upwelling, but very soon back to the land she did flee.
Do we have any questions?
So, could somebody get some, if I could get some help in mic passing, it would really be great.
Just take a second to turn it.
So how far out do the gulls go? Do they just go out into Elliott Bay, or do they go all the way out beyond the Olympic Peninsula when they're feeding?
Well, it varies. If you go on one of the bird watching tours going out, at first you got gulls all over the place, then you got out a little ways and there aren't any gulls anymore. And then you're into all shearwaters and albatrosses and that sort of thing. So mostly but we don't know how far out some of the gulls go in the winter. 'Cause we just don't know where they are, in the winter. But my suspicion is that they're probably pretty close to shore, because that's where the upwelling is, that's where the food is. Way out over you go to the tropical ocean, and look at that wonderful water down there. It's sterile, there's nothing there, that's why you can see so far. There's no upwelling there. So gulls are where stuff is brought up to the surface. A lot of other things are there too, cormorants and everybody else. But see, gulls can't dive. They can only get something within about 3 feet of this. They can plunge in a little bit, but they can't dive down. And so they're entirely dependent upon stuff coming up. And so even though the ones that are wintering off the west coast of South America are probably pretty close to land, because that's where the upwelling is and that's where all the food is. But we don't really know. Nobody tracks them out there. Nobody knows. We know that they're down there. Nobody knows where they are. But gulls stick close to land. That's where the upwelling is.
They seem to do a lot of scavenging around town. Is that bad for them, or what?
The gulls are very flexible. They do a lot. They've learned about garbage dumps. They've learned about a lot of places to go. Down out here, sometimes where stuff is spread out, the gulls go out and they get it there. They're very, very adaptable. And they've learned that human beings are a real source of food. And the gulls are most abundant around cities. If you want to go gull watching, don't go way out in the wilderness. Go stick around cities, because we produce all sorts of stuff, and they've learned how to, because they're really quite flexible. I mean, I'm impressed kind of with gulls, how much they figured out, how human beings provide nice food where there wasn't any before. And so they're one of the good places to watch for gulls is garbage dumps. They do it. They're pretty adaptable. So that's something, obviously, till we came around, they weren't doing. And that's why I think gulls are probably more abundant now than at any time in the history of North America, because we provide a lot of food for them in places where there wasn't much before.
I have another question which might be kind of silly. I lived in New York City, and the gulls there always looked dirty. And then one summer we went to Norway, and the gulls in the fjords were absolutely gorgeous, clean and white. And we always attributed it to the fact that New York Harbor was pretty dirty, and the gulls, therefore, were brownish looking. Was that true, or was it a gull that had brown plumage?
No, I think you're probably right, that New York is a good place for gulls to get dirty. And that reminds me, I forgot about the herring gull, which is the gull that's all over there. It breeds all across the boreal forest in North America too. And we do get herring gulls in the winter here, just a wintering. It's about the same size as the glaucous wing gull. It has black wingtips. And I haven't gone into the fact that since gulls like these take 3 or 4 years to reach full adult plumage, you got all sorts of and identifying gulls is a lot more difficult because they go through all these plumage changes, and I just didn't go there. I didn't think you wanted me to go there. But there's special courses in gull identification, and that the Cornell laboratories just come out with a special gull thing, because it's so difficult, because you've got all these, this is the first year gull, this is the second year gull, this is the third year gull, but New York gulls are dirty, yeah. But probably in places in Seattle they are a bit dirty too, although we're pretty clean here. But gulls get dirty around stuff, they know where to go after where the food is, and they don't care if they get dirty.
Okay. Any more questions?
You've talked about the age at which they're mature. How long do they live after they reach maturity?
Okay. This is a question that we're all curious about. How long does something live? What are the Guinness Book of Records and things like this? And although we are very, very curious about that, as a matter of fact, birds can live very long, but mostly they don't, because it's a difficult place out there. And for small birds, the annual mortality rate is about 50%. 50%. Well, look at this. If you got a pair of robins and they've raised 4 babies, next spring, there are now 6 robins. Next spring, they're going to be 2, if the population is stable, right? So there's heavy mortality out there. And now gulls obviously do not have such heavy mortality because you wouldn't be able to have a stable population if you took 4 years to mature if you had high mortality rates. So that is a rate that tells us that the mortality rate on these big gulls is probably pretty low. We don't know how low because what would you need to know to figure it out? What sort of information would you have to know what it is? We can get some note that say, we've got lots of gulls around that are 4 years old and older, and they're not breeding, and you know that they have all survived these 4 winters. And so the big birds like gulls and eagles and stuff like that have very, very low adult mortality rates. And that's the only way the populations are viable if they do. So probably some of these do live a long, long time, but most of them, you know, it's tough out there, the high mortality rate. So well, people think, oh, we got the same robin pair for the last 5 years. No, you didn't. You maybe had one of the pair, but they're new birds. Because the likelihood that both of that pair is alive 5 years later is infinitesimally small. So it's a rather complicated answer to the question, but it's tough out there, high mortality rates. The gulls, big, and not much against them. Adults don't have much predators on them, so they do pretty well.
What size? The gull nest that I can see out my window from the North Tower, it's fascinating. 3 years ago I started noticing them, and they come maybe 2 months earlier, and they just go around there and sniff down in the hole where they build their nest, like they're the same gulls that come every year. They know every little spot, like they haven't left. I know they're not always the same.
But one of the reasons that you see them come very, very early is because there is a limitation on the number of nest sites. And to get early and take control of a site, so they're around several months before they actually lay any eggs. And the reason probably that they're around is that there's competition because they're very limited nest sites. And that may be also why it takes them so long to mature. Is the kind of foraging that the gulls do is kind of complicated. It's not something, and nobody teaches them. And the birds in general, no adult teaches. But when the adults raise it and the adults leave and the babies are left and they're having to figure out what it means to catch fish, nobody teaches them. And they get pretty clumsy. And it takes a long time to figure this out. I'll take it aside. One of the easiest paper I ever wrote is that we were in Costa Rica on this about, and we would go down to Playa del Coco with my kids, and it was a beach in Florida. And during the middle of the day, when it was hot, everybody was taking a siesta, And I noticed there were brown pelicans foraging out there. And I noticed I could tell when they died, brown pelicans died, whether they got a fish or not. Because if they got a fish, they would bring the bill up like this, let the water drain out, and it would flip. And if they didn't catch a fish, they'd just come up. So I realized I could tell whether they got a fish or not in the night. And I could tell young ones from old ones. So I got a chair, a clipboard with a 2x2 matrix, young, old, successful, unsuccessful, bottle of air, and sat under the tree and scored. And yeah, young ones aren't as successful as the adults. And so these are, it takes a lot. I wish I could write papers that easily in general, but that was a few afternoons with my family at the beach and got enough. And yeah, it takes a while to figure, and gulls are complicated for it. It probably takes a while to figure that out too. So, and nobody teaches you. Nowhere in birds do they teach the babies how to do it. And you can see the young ospreys, and I know I'm supposed to dive somehow. What the hell do I do? You know, and they're pretty clumsy. And why birds don't help anybody, I don't know, but they don't.
Lots of questions and comments. When we see gulls out our window just soaring around in the afternoon, I mean, it looks beautiful, but what is their purpose? What are they searching for?
Very good question. I watch them, and one of the things I've noticed, because I sit out and watch, they're looking. And when they fly over, I can see they're searching. They're just not idly going by. They're figuring out what's going on. And it's interesting, because sometimes down here, the gulls, the food is dropped out, and the gulls swarm in there. You get one or two gulls circling, and all of a sudden they're 20. They are very, very alert to what's going on. It looks like, oh, no, I don't know what's going on. They're learning something about the environment.
Usually food?
Pardon?
Food or other things also?
Probably mostly food, because they use a thermal. There's not, well, when some food is dumped out here, it's kind of a form of upwelling. It's the equivalent thereof, and so it's mostly food, I think, yeah. But I watch them, and they're looking. And they're really looking. You can watch them. They are very attentive to what's going on.
Afternoon, because that's when the garbage gets put out.
Yeah, I mean, they know, and they watch, but it's amazing how fast. I've seen one gull circle, and all of a sudden they're 20. And you know, they're way over somewhere, they are watching. They look as though they're over, no, they're really paying attention, because, again, upwelling is temporary.
Yeah.
I watched for about 3 or 4 years from my apartment, and I saw the mating, and they came at the same time every year. And I realized that after a while, after those birds had gotten to be for maybe 3 months old, they were larger than the parents. And I couldn't figure that one out. Why are they larger?
Okay, this is very interesting, because as I told you, birds reach full size. And they don't grow anymore. So they are actually the same body bones. They're the same size as parents. But you can get extra size in the wings and the feathers.
Yeah.
And that's where the difference is. And you can see this in, you notice, you can add longer feathers, increased size. The way this is most notable around here is with hummingbirds, because the dominant hummingbirds have shorter wings, and they're maneuverable, and the younger ones have longer wings, and you go faster. And they're self-dominant, they can sneak in, and before the adult fight, they get out, but they can't fight, but they can flee faster. So you get age differences in the length of the feathers on the wings. And you can also, so the differences in size is entirely feathers. because the bones, once you get to the size, they don't change. But you could change bills a lot. I've given a talk on the puffins. You know, you take a look in the guidebook of what a puffin looks like in the winter, and you wouldn't believe it. That's all added in the spring. So bills are very flexible. Gulls get this thing. So you can play around with feathers. You can play around with bills and stuff. Once the bones are set, they're the same throughout life. No change.
Oh, okay, one more. What's the status of the convention center wanting gulls off the roof versus,
I don't know for
do you
sure.
know anything about
I
that?
don't know the details. The one place where we are able to watch from Joyce's apartment, this little side thing. And I know they don't like all the gulls pooping around on the top and engage in discouragement. I don't know the details there, but it's obvious now there just aren't any gulls on the main thing. And it's not that the gulls don't want to nest there. I think there's active discouragement. But does anybody else know the details? I don't.
Well, good.
Full ignorance, okay.
I think that we've learned a lot more about gulls than we should call them seagulls. So thank you very much for that. That has been just wonderful. I'm sure you can catch Gordon on the way to the elevator and he'll answer a few more questions for you.
I'll sit here for a while.
Thank you.
Thank you.
I don't suppose